Recording in progress. So welcome to Lecture 8. Today we start Project 7. So Project 7, you will choose one of your Project 6 environments. One and only one. So, interior, exterior, choice is yours, whichever one you decide to do. And this will have textures where needed. It'll have materials, obviously, for those textures. And those materials will be things like glass, metal, plastics, all of our dielectric materials and all of our conductor materials that we talked about. So, Project 7. One thing about Project 7 is if you are completely happy with your reference from Project 6, most of your work is done as far as references go. However, should you decide that you weren't really sold on maybe the floor or the sofa or outside the fabric on the outdoor sofa, this is the time to change it. Also, if you find that you're working and the texture or the reference you thought was really good until you start trying to find a texture for a certain pattern or style of wood, style of concrete, whatever it happens to be. If you're having trouble, you can change your reference to something that is easier to access, something that you like. Maybe it's not perfect, but the wood grain's better and you found a better texture than what you had before. Does that make sense? Questions? Anybody? Make sense in Zoom too? Okay. Thank you, Jerry. Okay. Katie, Maddie. Awesome. All right, so we have a bunch of downloads for you. For today, you will need the Lecture 8 new PowerPoint. This is for the second half of lecture. We're going to go into Photoshop and we're going to be making a seamless or tileable, sometimes called repeatable texture. We're going to take a brick wall, which is mostly straight lines, right angles. It's fairly simple for beginners to be able to make seamless. We've got the source Photoshop files for you. And we've also got an SAL logo, which we're going to be using in Lecture 10, and the Thermos logo we'll do in Lecture 10. And there are new templates for you. The difference between the Project 6 templates and Project 7 is Project 7, the close-up and the long shot are both color. There is no black and white here. Black and white was mostly for materials. Okay, so one thing to be aware of, not every object or every surface needs a texture. Don't confuse what you see on an object with needing a map or needing a texture if it doesn't need to. It's got to fit certain criteria. We're going to go over those criteria. And mostly it has to do with color. If you have more than one color on an object, like for example, your tabletops here, Full Sail, that kind of faux wood pattern on it, you can't do that with a single color. You need a map to be able to do that. Fabric, if it's got a pattern, a print, you need a map to describe that. You can't do that with a single color. So things like wood, this bread texture, the sofa in the exterior, it's got stripes in it. Even the sofa edges, the corners, they've got that kind of patchwork pattern where it's basically the same material, but they just go, one is vertical, one is horizontal, and they just kind of patch it together. So a lot of times people will just say, yeah, I'll do all my textures in Substance. No. You don't do everything in Substance if you don't need to. It's a lot of overkill. We save Substance for things that have visual wear and tear, or you want to alter them slightly to match the reference a little, whether that happens to be with the color map or the spec map or the bump map or the roughness map. Does that kind of make sense? Also, we're going to be doing this for lecture 8, 9, 10, and part of 11. Do not, please do not think, great, I got a lot of time to work on this. No, it takes a lot of work to do. Because in addition to knowing whether you need a map or not, say for color for this table here in the exterior scene. Right, just because you have a map doesn't mean that the UVs are set up for that particular map. You will probably have to adjust your UV shells so that they fit the pattern of your texture. So we'll talk a little bit about that also. All right, so next week I'll have office hours on Tuesday. Tomorrow and Friday I'm out of the office. You can still go to Discord to get help. On Friday, Anthony Bagsby, who's our ACD, Associate Course Director, he's our Substance guru. He will be doing the Substance lecture with you guys. Now, as far as what we require in Substance, we require you to have at least one wooden object and one metal object that you have done Substance textures for, and then exported them back into Maya. We are not rendering in Substance. Everything comes out, goes into Maya, gets an AI standard material, and then gets rendered out of Arnold. So from what I understand, you guys have not had much experience exporting out of Substance, right? You guys mostly do your work in there and then do a render inside. Right? Yeah, that's usually, that's the workflow for starting out. Obviously that doesn't happen with film or TV or games. You're going to do a lot of your work in Substance, but eventually it's coming out and going into Unreal, it's going into Unity, it's going into Blender, it's going into Maya, it's going into whatever else you have, 3D Studio Max. All right, so today we're going to talk about basic maps. Basic maps are diffuse, sometimes called base color. Arnold calls them base color. Unreal calls them base color. Specular maps, sometimes called just spec maps, roughness maps, and height maps. You guys have had some experience with normal maps. We're going to be using what are called bump maps, which are kind of simplified version of normal maps. It's basically black and white information that tells you where the height is and where the depth is. Works pretty well, but downside, it's only available or viewable or visually, it'll visually display when you render. We're unlike a normal map, which is meant for real time. basic, or we're going to be doing different file mapping methods. Today, we're just going to do the regular, basic file mapping with UVs. On Monday, we will get into 3D mapping with what's called a projection map, sometimes a decal projection or a sticker projection in other software packages. This allows us to alter something in 3D. So we project it in 3D space and we can move it around. After break, we're going to go over some basic Photoshop tools that we're going to be using. Most of you are probably well aware of these tools, but I still like to go over them anyway. And we supply you with a brick wall texture that we're going to make seamless. It's got a watermark in it. The edges of it, if it repeats, you can definitely see the left does not line up with the right. The top doesn't line up with the bottom. So you have seams all over the place. And the whole idea with a repeatable texture is using a small footprint texture that's square and then letting it copy or repeat itself across the surface. It saves a lot of texture space. Now, the trick is you want to make sure that that initial texture is big enough so that it doesn't pixelate or break up, become blurry, fuzzy when you render it or even look at it in the viewport. It's a little something called pixel density, meaning how big are the pixels in the window or your viewport or render. Yeah.
Could we find our own texture?
Yes, you are going to find your own textures. There's only a couple we supply. One is going to be the bread because the bread was modeled off of that image that we give you, which also, in a rare instance, doubles as a texture map. That usually doesn't happen, but in this case, it works. We give you some projection maps or decals, which you're going to put into your scene. As far as everything else, that's up for you to find. We do give you the brick wall we're going to do today, but it's not required that you use the brick wall anywhere, but you still can. All right. Any questions so far? Anybody, campus? Everybody good? How about Zoom? Any questions? Jerry's good. Maddie's good. Thank you. All right. Blaine's good. Joshua's good. Thank you. Okay, so let's get rolling here. So the first map that we're going to go over is the diffuse or base color map. All right, this will give you color information, but specifically when you need more than one color on a surface at a time. Because if you just put a color swatch on there, the whole surface is going to be colored with that single color. But if you've got something, polka dotted pattern, checker pattern, floral pattern, wood, carpet, concrete, bread, okay, that needs a texture map. More than one color, and also visual pattern surface detail. So when you need more than one color on a surface at a time, visual, any kind of visual surface detail. Okay, base color, diffuse maps, they get plugged into the base color, little checker button, that's the input connection. That will allow you to plug in a file node, We use file nodes because we are bringing these things in from outside of Maya. Okay. All your maps, textures, well, source files. Go into the source images of your project folder. No. Really? Okay, they go into source images of your project folder. That part is really important. A lot of people make the mistake of, oh, I got it in downloads, I'll put it in later. And then what they do is they hook all their files up into the downloads folder, all right? And then they move them later on, and that breaks the connection. So now Maya has no idea where to go. You don't want to put them on the desktop. You don't want to put them in any location except your source images folder that you have your project set to. Make sure you set your project to the proper folder. If you're doing the interior, please set it to the interior. Make a copy of your project 6. Put it in another location, change it to project 7. So you'll have an extra copy in case Maya decides to be Maya and chew up your project 6 while you're trying to turn it into project 7. So copies, versions, really important with all this work you guys are putting in. Make sense? Please. File management is crucial at this stage. All right, you also want to check, and probably you've already done this since project 5, even project 6, always check color management, make sure it's turned on, because occasionally if you switch from versions of Maya, it will turn color management off on you. So if you start out, say, at a company working, and like a year ago, you did it in Maya 2019, now they're working on Maya 2022, yeah, 2022 does some weird things, even with 2020 files. It turns off color management. It does all kinds of weird stuff. So anytime, that's another reason you never update in the middle of a production or a middle of a show. You never update software because things like that break or change. And they got to be tested before you make them live. All right. So one thing we're going to be able to adjust now with materials, if something was coming in too bright, you could always adjust the value of the material or the saturation of it or the hue, right? But now, if we're going to load textures in, there's going to come a time when your texture may look blown out with the lighting that you have. Rather than change your lighting for one object, what we do is we adjust the base weight. The base weight, since that's where your color map is going to go, that will adjust how much light the material responds to. With the base weight at 1, that means the material will respond to 100% of all the light that's in your environment. As we start to lower it, we're basically kind of limiting how much it gets. So you can see on the left, I threw a wooden texture that I found that worked good for the table. I threw it on with my default lighting, and you can see it's barely visible. And what I had to do is slowly adjust the base weight until it became visible and appropriate for my scene. I didn't want to adjust the light because that's going to change the rest of the environment. So base weight is a really good way to kind of bring textures, bring objects into balance with all the other objects in the scene without having to adjust the lighting for everything. Now, if you got a problem overall, yeah, you may need to adjust your lighting. But if it's one object or maybe one or two, you adjust them on a per object basis. All right, spec maps. This allows us to control specularity, or the amount of reflectivity, when we need it to have more than one level of reflectivity on a surface at a time. Oops. Well, let's kind of make that into a big giant fat eye. There we go. So, for example, I've got this mug here. Let me move it down a little bit out of the way of that. And you can see I've got some watermarks, some water stains on it, areas where I've had water, coffee, tea, whatever I was drinking out of that mug, and they dried on the sides of it. You can see that it changes the level of reflectivity. Areas where you have that dried liquid area, those dried stains, they are less reflective than the areas that look very smooth and clear. So we've got areas like this all along the lip of the mug. We got some areas here, some areas down here, right? And you can see areas where there are no stains. It's fairly glossy, fairly reflective, pretty reflective actually. But in these areas, like water stains, they're common. You can find maps for them all over the internet. Water drop stains, right? They are basically kind of knocking down the level of reflectivity on that mug, but yet the rest of the area remains higher in reflectivity or glossiness. So these maps get plugged into the specular weight section with a file node. So these are black and white maps, unlike color maps. Basically, black means no reflectivity, white means full reflectivity, and your maps are probably going to be somewhere in between. So by default, the weight is set at 1. When we plug a map in, all the areas that you want really reflective are probably going to be white or very light gray. All the areas you want to be less reflective are going to be a little darker gray or closer to black if they're fully knocked out. Does that make sense? So we've all got objects that have multiple levels of reflectivity. Like I can show you guys my tablet. You can see pretty clearly where there are areas that are more reflective and areas that are not as reflective. So I got some areas here, which are basically, you know, cloudy areas where either my hand's been on it or it's got scratches from the pen, and other areas where it's a lot clearer. And then, of course, I have the edges. Which are much less reflective because they're not smoothed out from me rubbing on them all the time. I usually don't go to the very edge of my screen to work, try and keep everything in the middle. You know, and then I have areas like this, the really smooth plastic parts. And actually, this is much cleaner than the example I'm going to show you when I took a picture. Because of COVID, I wipe it off a lot more than I used to, which is pretty disgusting, but yeah, I'm a pig, I'll admit it. So let's go on to roughness. So roughness, good example. Ugh, that's even too disgusting to show you. Okay, so back on my phone, got a case on it. You can see there's areas that are much rougher, got little marks all around. And you can see all those scratches and the rough areas basically wear off the reflectivity and make it look very rough. So a lot of times, if you have roughness on a surface, you also have less reflectivity. Now, sometimes your roughness map will take care of less reflectivity for you, and sometimes it won't. So I have any good fingerprints on here? Yeah, my fingers aren't that greasy right now, but you get the idea. So this one was my old phone case. You can see where I dropped it on the ground. It got scratched with concrete. I stick it in my pocket with keys. The keys ripped the heck out of the back of it. You can see how rough this area is, where it really knocks down the clarity of the reflections and consequently the amount of reflectivity. Now, like I said, sometimes roughness will do that automatically. Sometimes you need to add a spec map to knock it down even further. It depends on the results that you get with the roughness map first. But you can clearly see where you've got areas where with more than one level of roughness, this is when you need a map. And these are black and white also. Black means the area is going to be very smooth. White, going to be full rough. Your roughness maps will probably be somewhere in between. It'll be some level of gray. These are plugged into the specular roughness with a file node. So spec maps are black and white. They control the amount of reflectivity. Roughness maps are black and white. They control the amount of roughness. Like I said, roughness, reflectivity go hand in hand a lot of times. Right. Does that make sense? Roughness maps, any questions? Now, how do you know when you'll need them? Your reference will tell you. Do you have an object, your table, or your cutting board for the exterior, or even the computer desk sitting in the interior? Does it look like it's got scratches on it? Does it look like it's been roughed up? You know, it might have water ring stains, coffee stains, tea stains, whatever they are, from somebody obviously not putting something under their cup or glass. Maybe they were busy drawing, they drew really hard with a pencil or a pen and kind of indented the wood a little bit, which happens. Scratch it up. Maybe they were cutting with an X-Acto knife on the table, which I never did. I swear, Mom, I never did it. So all those different things are going to tell you if you need maps or not. And obviously you want your stuff, especially if you're going to do something like a cutting board where that cheese is. You want the cutting board to look like it's been used. You don't want it to look like you went to Target or Bed Bath & Beyond and bought a brand new one, put it down, put a piece of cheese on it, and it never got used. That doesn't tell a story. All that does is say, hey, I can make something look perfect. So simple roughness and spec maps. Like I said, here is a close-up of my tablet. So you can see definitely lots of little dried bits of whatever it happens to be in the environment. You can see scratches on the surface of it. You can see the edges where they are not as reflective. If you take a look, let me zoom in even closer. So areas like this. This is a really good example. Do we need a map here? What's that? We don't need a map. All right, so what we're seeing, result of color, result of roughness, result of spec, or is it a result of height, which we haven't gone over yet? What are we seeing here? This grainy part, this grainy pattern. Diffuse. Okay, how come I can see like lots of shine on it? And there's areas where there's no shine. And if I zoom in even further, how come it looks really sandy and coarse and grainy, almost like, you know, a noise that you throw onto something in substance? What are we actually seeing here? So is this piece of plastic smooth? No. Okay. So actually, we're not seeing this as a result of color. We're seeing it as a result of height. There are little areas that are indented. Those are all the dark areas that go inward, creating shadow when the light hits it. The areas that are a little brighter, they are up a little higher. They're actually picking up the light. So this, yes, but we need a height map. For us, that's going to be a bump map. To be able to get that grainy look. Because the color is fairly uniform, pretty dark gray. But what we're seeing is the result of height. All right, let's go even a little further. And before we actually get, let's go here. All right, so result of color, or what is it? Okay, why? Roughness map? Okay. Why? There is no wrong answer. I'm just going to ask you why, because I want you to be able to support why you think it's going to use that kind of map. Okay. Let's switch over from this to this. Now, what are we looking at? Is that a result of color? So we got some areas that have a shine to it here. So now we can't say it's not reflective. Why? What are we looking at? Okay, that's good. That's a good defense. So we're looking at a bump map. Now, as far as a roughness map goes, maybe, but your bump map may contain enough of that information so you don't need the roughness map. All right, so roughness, no. Color, no. Bump, yes. Because all the little dark valley looking areas, those are all indented. All the areas that are lighter and look like they come up, almost like terrain, where you've got rivers that are lower than the mountains. So all of those areas that have shine to them stand up a little bit higher. And the fact that we have a little bit of visible shine on it, like right here, you can probably see this is where the light source is. Or probably all the way back here, and it's shining on all of this. And it almost looks like somebody didn't flatten it out completely, because it looks like some areas are a little higher than others. We got darker areas here, we got lighter areas here, almost like there's little bubbles. Okay, good. This one might even be a little easier to see. The fact that it's whitish or light gray. Can see all those dark little valley areas get indented. All the other areas a little brighter, and they pop up off the surface. So far, we have not seen any color variation, right, between the brown and the black and this kind of cream leather. Now, what about something like this? So what are we looking at here? Let me see if I can, oh, not very big, disappointing. Or something like this. Maybe this is a little easier. Uniform color? No, I would agree. Uniform color? I would argue no. You got some areas that are darker, and it doesn't look like it's a result of little bumps on the surface of it. That looks like that's kind of the natural grain of the leather. Some areas are going to be a little brighter. Some areas are going to be a little darker in hue. Now, if we zoom in a little bit more, we can definitely see that there is some surface relief in there, areas that look indented, areas that look like they come up. All right, let's see. Yeah, let's do this one. Let's not. I don't want you to take me there. I don't want product. Go away. All right, so this. What are we looking at here? Pattern. I would agree. I would also probably say some of this needs to be modeled. All these big diamond shapes really need to be modeled into the model for it to look accurate, because we're not going to be able to get those kind of valleys with a bump map or even a normal map and have them look real. They really need to be built from the model. Now, as far as the little holes go and that little leather kind of, fractally looking terrain area that leather has, all the little fine little channels and then all the areas that are raised up. Yeah, we can do that. But for this requires some geometry to be made. All right, so let's look at something like this. Wall. What are we looking at here? Forget the floor. Do we need maps for this? Any variation in color? No, probably not. How about, we can't really see, it's pretty far away, can't really see if there's any visible bump or visible roughness or visible speck. Almost like our full sail walls. You look at them straight on from this distance, they all look like a solid color. Do they look like they have any bumps in them? Not from this distance, but if you walk up to them and get about 2 feet away, you can see that it has kind of an orange peel texture to it. There's areas, it's got all kinds of little bumps all over it. So level of detail to the camera. Remember, you guys were taught to model in level of detail. Stuff close to the camera, you put a lot of detail in. Stuff that's going to be far away, you can make impressionistic. Same thing with texturing. If you don't see that orange peel texture, why put it in if it's never going to appear in your camera? Now, the thing is, if your camera moves and you get a close-up of that wall, then you need to have that orange peel in there to support it. Right? This. I don't know if I would ever have that on my walls, but there you have it. Sponge design, which is really popular. You get different shaped sponges, a couple of different colors of paint, and put them all over. So this pattern, more than one color, it's definitely got some kind of, well, it's got flowers, it's got a couple of deer. That would require what? Yep, texture, where would it go? Yep, so we would definitely need a color map for this. Now, would we need a reflectivity map for it? Possibly. It kind of looks like that gold color in there is a little shinier than the background color. So if that is the case, spec. maybe. Really need to find some more reference of this wall so you could really get a good idea. This for sure, definitely. No question at all. This ceiling, walls, feel free to chime in out there in Zoom also. We need any maps to describe the walls. No, I would agree. Yeah, can't see anything. It looks like a solid color. All right. Does that make sense? All right, so now we get into bump maps, simple maps, bump maps, height maps. Another black and white map allows us to control what we call visual surface relief. Or I should say more like the illusion of surface relief. It has to do with the angle of the normal to the angle of the camera and the angle of the light. Whenever the normal faces the camera sees the most bump effect. And as the normal starts to face away from the camera towards a 90-degree angle, remember, we're always measuring stuff at 0 degree when we look at it directly and 90 degrees on the sides. When the normals start to face away from the camera, the bump effect gets less and less. So by the time it hits 90 degrees, there is no bump at all. It's all illusion. If we actually want surface relief there, we either have to model it or use something like a displacement map, which we'll get into in our last lecture. So white looks like it's raised, black looks like it gets indented, gray somewhere in between. If you want no bump effect, guess what? 50% gray is no bump. So believe it or not, a lot of these maps, spec maps, roughness maps, bump maps, height maps in general, start off with a 50% gray fill. And this way, if you want, for example, bump, if you want stuff to look like it raises up off the surface, the color needs to be lighter than 50% gray. If you want it to look like it's indented, it goes inward or etched, then it gets darker than 50% gray. Now, these get plugged into the geometry section of the material down under bump map. Click the checker button. We plug a file node in. Now, when you plug the file node in, you get a Maya utility for free. So basically, your file doesn't go directly into the material. It goes into what's called a bump utility, a 2D bump utility. There's two parts inside that bump utility. There's bump value and bump depth. Value is where your file gets plugged in because we're using value information from your file. Light and dark. Anytime you see value, think lightness and darkness. That's where our texture goes. Our file goes into bump value. We adjust the amount of bump in bump depth. We've got a little slider in there. The slider is right in the middle, and it can go positive and negative. And you would say, why would you want it to go negative? Well, if you've got a bump map and it's giving you the opposite of what you want. There's areas that you want to have raised up, areas that you want to have lowered, but they're reversed. So if you put your bump depth slider into the negative, it flips everything around. Negative bump depth numbers reverse the direction of the bump. This way you don't have to go back into Photoshop or back into Substance and redo your bump map. You can just kind of invert it inside the utility. Questions? Zoom, campus so far? Did I lose anybody? Okay, no questions. All good. Thank you. All right, so when we plug maps in, we're using a file node. That file node, so before a texture was put in here, this was a file node. With a file node, when you texture map something in, you always get a 2D placement. Well, it's actually a place 2D. Place 2D texture. This allows some basic controls, some basic UV controls. But this requires your UVs on the surface of the geometry to be properly done. You can move things like shift them and rotate the UVs and make stuff repeat, okay? But you can't map something in this utility. So this kind of looks at the UVs on the surface and places your file node appropriately based on those UVs. Like I said, it lets you have some control within the UV frame. Remember, UV frames are 0 to 1, right? Got 0 down here, you got 1 here. So if you've got your texture here, well, if you want to reposition it, you can kind of shift it over if you want, up and down, left and right. You can even rotate it inside here. You can also make it repeat if you need to. Like I said, basic controls, but it will not take the place of the UVs that are laid out on your geometry. Now, we're going to get into other kinds of mapping. On Monday, we're going to get into projection mapping, which allows us to take a 2D texture and put it in 3D space. But for today, just file mapping. All right, so let's take a look at some of these maps. And I'm going to utilize the exterior day scene that I started in lecture 7 with, I added some glass in. And let me see if I can find that. Let's go. Zen Garden. All right, so I'm going to copy this. And let's go to project 7. I got a project 7 folder. Here we go. And let's get all this stuff out of here. Oh, let's put it up here. All right, so I'm just going to paste, and I'm going to rename this project 7, and this will actually be lecture 8. So it's going to be kind of my guinea pig or host scene, just to kind of demonstrate what these maps are doing on a simple piece of geometry. Wait for Maya to start up. Now, basically what I'm going to do, and you can follow along if you want to, I'm going to use my Zen garden, and I'm going to make a sphere and sit it on the table. And that sphere is going to be kind of my guinea pig or host geometry, so I can demonstrate, color maps. Well, color maps I want to demonstrate on the table itself, but I can demonstrate what spec maps do, what roughness maps do, and what bump maps are doing, without being distracted by anything else. All right, so let's set project, which is always a good idea. Zen garden, set. Let's open up, come here. And with any luck, my dome light image is there. If not, I will have to reset it to this project. Let's see what we get. Yep, looks like it's there. All right. So let's do this. I'm going to render out from perspective. Good enough. Make sure I didn't crank anything up ridiculously. Okay. That's not too ridiculous. So nice and bright, got shadows for glass. And actually, let me do one thing. Let me go find the original project 5 scene file for this. Daytime, there we go. Oops. Day. All right, there's my table. And let's take a look at the UVs here. UV editor. Let's select it. So there's UVs. I'm pretty sure those are the default UVs. So I'm just going to take a screenshot of this. Now I'm going to go back to my project. '7 folder. Let's open this up. Let's take a look at this. And what do we got as far as UV go? Looks like they're the default UVs. Good enough. Yep, they do look like default UVs. Okay. Alrighty then. Looks like I got lucky. So I've got, basically I was trying to do the Zen garden like it exists in the reference we give you guys in project 5. The photo reference. And I was trying to base, I don't think I have any better pictures of that table. Yeah, they're all pretty much the same. All right, so wood table, wood grain. If anybody's got better pictures of it, you'll understand what I'm talking about here. And I probably have some other pictures on my phone somewhere from when I did this, but the reason I'm doing all this is because I want to assign a brand new material to it and put a texture that I found. And I got my textures inside there. And here it is. Found a bunch of boards that I thought worked pretty good for that table. Wood planks. They were very similar to the Zen garden when it was new. So I found that. I want to put that on my table. So assign a brand new AI standard surface to it. So Zen garden, wooden table. And if I have a color map, let me zoom in actual size. There we go. So we can see it's got some wood grain in it. So my color map is going to go into the base color. And when you click on that checker button, it brings up the create render node. Create render node, we want to go on the left to 2D textures, and there on the 4th selection on the right is file. We're plugging a file node that I got off the internet, a JPEG, in as my texture. So when I click on that file node, it brings me to file here and basically is empty. So it's going to show up as nothing. So let's plug our texture in. Zen garden, wood planks. And let's see how that texture looks with UVs. All right, so I must have altered these because I'm pretty sure the default UVs don't line up like this. Yeah, I'm pretty sure I must have laid it out. So I must have gone back and put it in there. Anyway, if you drop a texture in and yours don't line up, take a look at the UV shells. Try and get them to line up with your texture pattern. Now, had I brought my boards in vertically, then I would have had to rotate my shell to be able to get my pieces to line up. So like I said, in this case, looks like it lines up pretty good. Now you can see it's not bad. Let me deselect that geometry. Now you can see my viewport shows me one thing and my render view shows me another. Right? The render view has lots of light. Now, rather than me adjust my light, that would involve the dome light, the directional light, bring everything down, which will darken the entire scene. I don't want to do that when clearly it's this single surface that's doing it. So in this case, this is where I would go and start adjusting the base weight. Watch what happens when I turn it down. As I lower the base weight, it responds to less and less light. Now, the downside is you can make it look like it's on an overcast day. So you got to be really careful that the amount of weight you adjust matches your actual environment. You know, for me and this scene, somewhere around 0.5 seems to work because it's kind of a yellowy, warm piece of wood, got warm color in there from the sun hitting it. It's adding all that extra warmth in there. Remember, lighting's additive. So is color. I don't want it to be dark where I lose that kind of almost blown out. I want to get it to the point where I still got a lot of lightness in it, and it could look like it's blown out in certain areas. Because this is bright, it's 10:30, 11 o'clock in the morning, a lot of sun. But adjusting the base weight will help you kind of bring that texture into balance. Does that make sense? Questions? About in Zoom? Anybody got any questions? You got to be careful. Don't overdo the base weight. But it is a tool you can use to help you. All right. Jerry's good. Maddie's good. Katie's good. Thank you. All right, let me stop that. May as well save this. Put it in there. All right. So what I'm going to do at this point is create a polysphere and put it on the table. And obviously scale it so it looks like it can go on the table without, you know, being the size of a planet. All right, so let's scale it down. And it's close enough to the table. Should look like it's seated. Let's assign a brand new AI surface to it. Shift T. It's going to be my sphere. And let's render. So there it is in all its sphery goodness. Now, the one thing I didn't adjust was my table. And it's actually pretty shiny. My table is pretty diffuse. If anybody's actually gone to the Zen garden, those tables are outside in the elements all the time, so they are not smooth. They do come in once a year and put a coat of lacquer on them or varnish, but that is soon just kind of beaten right up. Sun, rain, elements outside. There we go. So that's going to be pretty diffuse. The sphere, on the other hand, and I'm going to lower my roughness all the way. And let's make it a little bit on the dark side so we can see. All right, so you can see it is by default pretty reflective. Bring it down a little more. There we go. Now, right now, I've got uniform specular weight, which means I've got uniform reflectivity. What if I don't want uniform reflectivity? Well, in that case, then I need a spec map. Now, what I'm going to show you guys is I'm going to pick one of Maya's built-in textures. Maya's got a bunch of built-in procedural textures. One of them you've probably used is the checker pattern. Simple black and white. The simple black and white pattern will show you where reflectivity is and where not roughness, but where no reflectivity is. So spec map gets plugged into specular weight. Now, before we do that, I do want to go over really quick, and we're going to go over this pretty much almost in every lecture, how the hypershade works. Anybody here familiar with the hypershade? You guys get to play with that at all? Okay, so you know the hypershade is right here. You usually get 5 areas. You'll get a browser, you'll get the create area, you'll get the node editor, which is actually the hypershade. You may get a material viewer and also property editor. The property editor, material viewer are garbage. I close them out. The material viewer is just like having IPR run all the time. It constantly tries to show you what a material will look like in the hypershade in Arnold. And it'll show you in, you know, one of those shader balls, or you can just do a ball. It's still here. No, get out of there. Get out of there. Nobody likes you. No, I don't want a viewport. I want, there it is, material viewer. Now, notice that this is pretty happy to try and dock anywhere. Arnold sphere. And if I want to, I can also get the property editor, which is a lot like property editor is an awful lot like, no, come on, get up here. There we go. Property editor is very much like the attribute editor, but it does truncate some stuff occasionally. But if I want my attribute editor, I got it right there. I really don't want to have all that stuff take up space, so I get rid of them. By the way, there is no way to reset the interface for the Hypershade unless you reset your Maya preferences, which means trashing them and then having them rebuilt again, which is totally doable, but not worth it. So the only three things you really need is the browser, you need to create, and you always get the node editor. There's no way to remove this. Now, I've got my sphere in here. It's my sphere. I want to see what my sphere looks like. I want to be able to graph it. Now, graphing in the Hypershade, you guys know how to graph things in the Hypershade? So basically, you find your materials up here in the top. So there's materials, textures, utilities, in tabs up here. So here's my sphere. If I want to be able to see what that looks like laid out down here, I can right-click on it, and I get a contextual menu and just basically go straight down to Graph Network. And what that will do is drop my material in to the node editor and show me my material hooked up to the shading group. Shading group, material. I don't have anything else plugged into here. I don't have any textures or anything. So it's just a material. The shading group is responsible for giving the renderer all the information about what the material is assigned to, how many pieces of geometry, are there any utilities, are there any textures, what is it plugged into, how many lights affect it. That is the shading group's job. So you'll always get a shading group when you create a material. You need it. Now, this is basically just, a nodal display system. You've got areas which correspond to the inputs in the attribute editor. So base, this is going to be your base weight, even though it doesn't say weight. There's your base color, diffuse roughness. You get into the spec, you get into transmission. So these are all the basic inputs you need. Now let's compare that with a material that has a texture plugged into it, like the table that I just did. So now, this area here in the node editor has something in it. When I graph something new in, it will clean up that node editor area and just display what I want to have in there. So here is my wooden table. So let's graph that. Right click on it, go to Graph Network, and notice that it replaced the sphere that I had with the table. Now, in the node editor, you can zoom in and out just by, kind of zooming in, hold Option, use your mouse wheel. Can right click and pan. So you can see that we've got my affordable wood texture. The out color goes into the base color. Which is right here. And here is my place 2D texture. So place 2D texture is basically driving where this texture goes on the table based on the UVs that are laid out for the table. All right, so the place 2D, as I mentioned, has things like coverage. And by default, the coverage is set to be 1:1. Remember, this is all based on your UV shell. Your UV shell is 0:1 space. So when something is covered 1:1, that means it's covering the entire UV shell. All right, so this first column is U, the second column is V. Translate frame, this will basically allow you to shift the texture around in that 0:1 space. So if you want to rotate it, so watch what happens if I rotate this wooden texture. We're rotating the whole UV frame. So right now it is wrapping all the way around in U and all the way around in V, which you want it to do with the texture. And it's set to repeat right now at 1, meaning it is just putting that texture on as is from the file. If I try to make it repeat, this texture is not meant to repeat. If I make it repeat by typing in, well, let's get ridiculous and type in 22. Well, no, that's probably too ridiculous. Let's go with 10. And maybe even a few. Let's go 5. So you can see it's like it's repeating that wooden pattern. Let's go 3. So it's repeating that wooden pattern 3 times. It's taking that whole image that I have and making it repeat itself by making it smaller. And as it repeats itself to make more copies, it has to make itself smaller to fit in the frame. So now if I bring up my UVs, you can see what it looks like repeating. Well, it may look cute, it may look, kind of funky, but these boards are modeled to be a single piece of wood. So let's put that back to 1. Now, anytime I want to get back in and adjust things in a material, like for example, I can jump from here to the material all in one shot without having to go through the texture or go around it. The nice thing about the Hypershade is it's nonlinear. You can click on something, it'll display the settings. You don't have to start with the material and then go, well, I want to get to the place 2D, so I got to go into color. I got to go in, there's file, maybe I have a tab here. You may have to go through several networks. Whereas here, you can basically just click and change it. Does that make sense? Questions? All right, so we're going to be doing the UV editor, or not UV editor. We're going to be doing the Hypershade a lot because this is how we can make and break connections a lot quicker than we can trying to do them plugging one thing into the material and then another thing into another node. we can see exactly what the whole network looks like and then make and break connections here. Now, to clean up this area in the hypershade, you want to click this little button, kind of looks like 3 little stars, almost like a Subaru icon. Click on it, that will clean up the hypershade area. Now we can create nodes here, but anytime you create something, it is not connected. So at this point, we're just going to make connections basically inside the attribute editor just to get rolling. All right, so the whole reason I went to do that is to show you what the different nodes look like inside the hypershade with something and without. So let's go back to our sphere. The whole idea is what I want to show you guys is what happens when we plug in a Maya checker pattern to control more than one level of reflectivity on the surface. So spec maps. So Yen said, do we have to find a texture that looks exactly the same like the references in project 6? Yes, Yen, you want to try to find a texture as close to your reference as possible. If you can't find it, then you need to change your reference to match the texture you find. Does that make sense? Yeah, that's why you have reference, because that is your target. You're welcome. That's a good question, a really good question. All right, so with my object selected, going into the material, attributes, specular, weight, clicking that little checker button brings up my create render node. I want a 2D texture, and you can see the very second selection from the top is a checker. Now, before I click that checker, let me keep this image so we can compare it. So now you can see I had uniform reflectivity across the entire surface. Now I've got some areas that are diffuse and some areas that are reflective. The black areas is basically diffuse. That's where we've shut down the reflectivity weight to 0, which black equals 0. And white equals 1, so that would be full reflectivity. Now, honestly, most objects don't have full reflectivity or not. They may have different levels. So for example, if I want the black area here to have a little more reflectivity, I can just crank it up a little. And that's why I like this little checker pattern, because it lets me adjust it so you can see what happens when you start letting a little bit of reflectivity in and an area where maybe you knock some reflectivity down. So now we've got 2 areas with different levels of reflectivity. All courtesy of a map. Make sense? So your map, whether you will go into Photoshop, draw it by hand, go into Substance, make it, or you grab it off of an object and, desaturate the layer and basically adjust everything so that you get less contrast, you get less value. You start making your own reflection map. It's going to have different levels of gray, really dark, really light, maybe something in between. All right, questions? All right. You know what? It's 2:35. I think we're going to take a break here. When we come back, what I will do is I'll show you roughness maps, we'll do bump maps, and then we'll figure out why we need that brick wall to be repeatable. Then we'll go into Photoshop and I'll give you an overview. Basically, it's a PowerPoint tutorial I have for you guys, which you download, which will kind of go through the steps of making something repeatable in Photoshop. All right, any questions before we take a break? Yes, no? How about out there in Zoom, questions? Jerry's good, thank you, Jerry. Anybody else? All right, let's see, what time do we want to come back? So let me save that, let's save this. And let's see, let's come back at 3 o'clock. Come back at 3 o'clock. Like I said, we'll do roughness maps, we'll do bump maps, and then we'll get into doing seamless texture. All right, see you guys at 3.